In a situation where we apply 100 Newton force vertically on a spring to elongate it like this, in this direction down, such that it changes its length from 10 centimeter to 12 centimeter. In this case, we say that x is equal 2 centimeters. It's plus, therefore we can see that the spring is elongating. According to a law called Hooke's law, it says that always the force applied on a spring is always equal to negative a constant related to the stiffness of the spring. So if the spring is really hard to compress or elongate, this number k, which is called spring constant, is a big number. If it's a smooth, soft spring that you can easily compress or elongate, then k, which is the spring constant, is a small number. So according to Hooke's law, the applied force, this is the applied force here, is equal to minus k multiplied by the change in length of the spring. So if we put the value here, 100 Newton equal minus k, of course we need to change this from centimeter to meter by dividing by 100. So this is 0.02 meter. Then you will get k is equal to, in absolute value, it's equal to 100 divided by 0.02. So as you can see here, the unit of this is Newton per meter. So this tells you that how much meters will elongate or compress under the value of, or the influence of 100 newtons. The answer here is, if you take 100 over 2, it's 50. I think it's a 50 here, divided by 100, divided by 10 to the power minus 2. I think it's 5,000 Newton per meter. So this here is called the spring constant. So this thing here is called Hooke's law. In Hooke's law, you should never put Li or Lf. You just put x, which is the change in length, this one. Hooke's law is amazing if you want to find the spring constant. Every spring has its own constant that we call spring constant or stiffness constant, because it describes the stiffness of the spring.